Hey, welcome back. In this video, we will solve the remove element question on LeetCode. Okay. So here, given an integer array nums and an integer value, which is the value, basically remove all the occurrences of value in nums in place, and the order of the elements may be changed. Okay. Then return the number of elements in num which are not equal to the value. Okay. So consider the number of element nums in nums basically which are not equal to the value to be k. So to get accepted, you need to do the following things. Change the array of nums such that the first k elements of the nums contain the elements which are not equal to the value. The remaining elements of nums are not important, as well as the size of the nums, and then return the k. And here we are having this one. So don't worry about this one. So it is the test code basically, but here we will have the example here. So as you can see, 3 due to 3, so value is 3. Then what exactly we are doing currently right now, we are moving all of the values which are not equal to this particular value, which is 3 currently right now, okay, to the left. All right, and returning 2. Why is that? Because we are having 1 and 2 elements here. Okay, so this is basically that. And here is another example which is a little bit more complicated and which we will see in action in a moment inside of the drawing tool. Okay, so 0 1 2 2 3 0 4 2, and the value is 2. So we are removing all of the values which is 2 basically. We don't care about them, and we are basically moving all of the elements to the left which are not equal to 2. Okay, so that is why our output is 5 currently right now, and the nums array will be 0 1 4 0 3. Okay, so this is basically that. All right, so our output will be 5. So let's do something like this. So I will do 0 1 2 2 3. So let me just go here. So let's explain that a bit, how we can solve this problem. So 0 1 2 2 3, and then we are having 0 4 2 0 4 2, and the value is equals to 2. All right, so now how we can solve this particular problem? So to solve this particular problem, we can use a 2-pointer approach. So our first pointer will be at the first element here, and our second pointer will be at the last element here. Okay, that makes sense. Now what we'll do, we will check. What we will check? We will check if this one, so the element inside of the left pointer is equals to the value. Currently it is 0, so it is not equal to the value. Then what we can do, we can move our pointer here. So here we can move our pointer to the right one. Okay, all right. So now once again we will check if this value inside of the left pointer which we are having currently right now, if that is basically the value. No, it is not. So it is 1 currently right now, and the value is 2. Okay, so what we will do, we will move the pointer once again to the right. Now as you can see, currently right now we will check once again if the current value which we are having currently right now, okay, if that is the equal to the value. Yes, it is equals to the value. Then what we will do, so we will basically grab the value in the right pointer here. Okay, we will grab the value inside of the right pointer, and we will basically replace that particular value here. Currently right now our right pointer is pointing at 2, and our left pointer is pointing at 2 as well. So we have replaced that. So just imagine that we have replaced that. So once we have replaced, then what we will do, we will not change our left pointer here, because as you can see currently right now it is still pointing at 2. So what we will do, we will change our right pointer at this moment. So this is our right pointer. So I will just point it out here. Okay, now once again we will check if the value inside of our left pointer, if that is equals to the value. Okay, yes, it is currently equal to the value, it is still 2. Then what we will do, we will swap. So here what we'll do, we will not swap. Basically what we will do, we will just grab this value and put it down here. So here I will just remove this one and put it down at 4 here. Okay, and once we have swapped, then what we will do, we will just move our right pointer to here. Okay, now once again we will check. What we will check? If the value inside of the left pointer is equals to the value, it is currently not, it is 4 currently right now. Okay, so it is currently 4. So what we will do, we will increase our left pointer. So I will just grab it from here and increase the left pointer here. Okay, all right. Now once we have done that, once again we will check if the value which is here is equals to the value in the left pointer. Yes, currently it is equals to the value in the left pointer. So what we will do, we will grab the value in the right pointer and just replace that here. Okay, so I will just get rid of this one and do 0. Okay, all right. So if that is the case, then what we will do, we will basically grab the left pointer here and point it down here. Okay, and now after that we will check. Now once again we will check if the value in the left pointer is equals to the value. It is not. Then what we will do, we will just grab this pointer and point it down here. Now as you can see, our pointers are overlapping. So at this moment of time, basically, okay, at this moment we will just return basically our right pointer, which is this one. Okay, so when our pointers will overlap, then basically our algorithm stops. All right, and at that moment we can just return the right pointer which we are currently having. Okay, so now as you can see, let's see what exactly will be our right pointer pointing at. So first of all, our right pointer was basically initiated or instantiated with the length of our numbers. Okay, so this is the length of our numbers. So currently right now, so what exactly is the length? So let me just do something like this. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, so our right pointer is pointing at here. So 1, 2, 3, 4, 5. Okay, so our right pointer, basically the right pointer is pointing at 5, which exactly is our output which we want. Okay, and now you might be wondering like, hey, there is another 2 here. So this particular space basically, so I will just do something like this particular part we are not interested in. Okay, so as you can see inside of the question, it has been told like the order of the elements doesn't matter and we do not care about the remaining elements. Okay, we just care about these particular elements here, which is basically non-value. Okay, so here inside of this particular values, basically there is no 2, right? And that is what is matters. All right, so this is basically the conceptual overview. So now let's go to LeetCode and code it up. Okay, before moving to the code, let's discuss about the time and the space complexity real quick. The time complexity, okay, let me just do something like this. So the time complexity, that will be big O of n. Okay, because we are traversing through the whole array of numbers. And space complexity, that is big O of 1. Why is that? Because we are not allocating any extra space to solve this problem. Okay, so now let's go to LeetCode and code it up here. So all right, we are inside of the LeetCode here. Okay, so let's declare our left pointer, which will start at 0, and our right pointer, which will start at the length of our array, which is in our case nums. All right. Okay, so while left is less than right, if that is the case, then we will check if the nums of the left pointer is equals to the value which we are provided. Okay, so as you can see, here is our value which we are getting here. If that is the case, then what we will do, we will replace the left pointer value, basically the value at the left pointer inside of the nums array. So to do that, what we can do nums of left equals to the nums of. So remember one thing here, this right is the length. Okay, so it is currently overflowing, right? Overflowing the array. So we have to do right -1. Okay, all right. And then we have to decrease, once we are basically replacing the value, we have to decrease the right pointer, minus equals to 1. Else, if that particular value is not equals to the value, so else if the number which is inside of the left pointer is not equal to the value, then what we want to do, we want to increase the left pointer. Okay, so else left plus equals to 1. Okay, and after doing everything here, we can just return the right pointer here. Okay, simple enough, right? So here, what exactly is the time complexity? Once again, the time complexity will be big O of n. And what exactly is the space complexity? That is basically big O of 1. Okay, I hope that makes sense. All right, so this is our code basically. So we are having the left and the right pointer. We are checking while the left and the right pointer are not overlapping. Okay, so we are checking if basically the value inside of the left pointer is equals to the value which we are provided. If that is the case, then we will basically replace the value of the left pointer with the right pointer -1. Why the right pointer -1? Because our right pointer is instantiated with the length of the number. Okay, and that is basically overflowing currently right now, right? So we have to basically do right -1. Okay, and then we have to decrease the right pointer, else we have to increase the left pointer, and at the end when our algorithm stops, basically we have to return the right. All right, run the program, accept it and submit it. All right, as you can see, it is quite efficient as well. Okay, awesome. So in this video, we have learned about the remove element question in LeetCode. In case if you have learned something from this video, please like this video, share this video, and subscribe to my channel. That will help me a lot. Thank you so much for watching, and I will see you in the next video.